So this problem's a little bit of a longer one when it comes to performing calculations. So I jumped ahead and I already drew the process out for us. So we have a combining process here where we are combining two streams of both containing ethanol and hexane at different concentrations. And we know we want to figure out the final density of our of the tank once we fill it up, and we are going to go ahead and start doing that. So first we're going to do balance here on stream M1. So the density of ethanol 0.1 plus density of hexane 0.9 equal to the final density of 0.68. And here we're assuming that volume is additive. So then from the density of M2 we have density of ethanol 0.9 plus density of hexane 0.1 is equal to 0.78, which is given, and combine this information and then solve the linear equation here. We have that x is equal to 0.68 minus 0.9 y over 0.1, which is equal to 6.8 minus 9y. Plug that in here. And we have 6.8 times 0.9, 1, 2. So then we have that y is equal to 675, x is equal to 0.7925. So there we can figure out the final density of M3. Which is going to be equal to x times 0.6, was the concentration of ethanol, and then y times 0.4, which is the concentration of hexane. And that's going to be equal to our mixed density, and that is going to be 0.7925 grams per centimeter cubed times 0.6 plus 0.6675 grams per centimeter cubed times 0.4, and calculating this out, we get that the density of the final mixture is equal to 0.7425. So that's the density of the final mixture, which is one of the values we were asked to solve for. And now we are going to find, we're going to find M3. So to find M3, we use that handy equation that mass is going to be equal to rho times V. And we just figured out rho, which is 0.7425 grams per centimeter cubed. And we know V because we know that we have a 500-gallon tank. But we just need to get that 500 gallons in terms of centimeters cubed. So we have 3,700 or 1 centimeters cubed per gallon. And that is going to equal 1.405 times 10 to the 6 grams. So that is our final mass within the tank, so M3. And so now we need to figure out the mass and volumetric flow rates of the two feed streams. So what we're going to do is we're going to do a balance on E and a balance on H in order to find M1 and M2. So our balance on E is going to look like 0.1 M1 plus 0.9 M2 is equal to 0.6 M3 over 22, because M3 is just a mass. It is not a mass flow rate like M1 and M2 are. So we do have to divide by 22, which is the number of minutes, in order to get that M3 in terms of mass flow rate. So we have here that 0.1 M1 plus 0.9 M2 equals, so 0.6 times M3 divided by 22 is equal to 38,000 grams per minute. Let's put that in kilograms per minute. So that's gonna be 38.327 kilograms per minute. And same thing for the balance on H. So for the balance on hexane, we are going to have that 0.9 M1 plus 0.1. That doesn't look right. 0.1 M2 is equal to 0.4 M3 over 22. And just rewriting that again. .4 times 1,405,333 over 22 over 1,000, and that is 25.55 kilograms per minute. Now let's figure out M1 and M2 from those that linear set of equations. So M1, we're gonna put this balance on E in terms of M2, so we're gonna solve for M1. M1 is equal to 38.327 minus 0.9 M2 over 0.1. And simplifying that, we have 383.27 minus 9 M2. Now let's plug that into our balance on H. So we have 0.9383.27 minus 9 M2 plus 0.1 M2 is equal to 25.55. And just simplifying this out, minus 8.1 M2 plus 0.1 M2 is equal to 25.55. Now we are going to solve for M2, and that is going to be 344.9 minus 25.55 divided by 8, and we get that M2 is equal to 39.9. So now we have that M1 equals M1 is 24.17 kilograms per minute, and M2 is 39.9 kilograms per minute. And I'm sorry, we're not done. So we got the mass flow rates of the two feed streams. Now we just need the volumetric flow rates of those two feed streams, which is pretty easy. So we know that governing equation, density is equal to mass over volume. So we know that rho 1 is equal to 0.68 kilograms per liter. So then we know that V1 is equal to M1 over V1, which is equal to 24.17 kilograms per minute. And then, sorry, not V1 here, rho 1. And then rho 1 is 0.68 kilograms per liter. And we get that V1 is 35.5 liters per minute. And then for V2, we know that rho 2 is 0.78 kilograms per liter. So V2 is M2 over rho 2, which is equal to 39.9 kilograms per minute over 0.78 kilograms per liter. So 51.15 liters per minute is going to be V2.